Hello, ladies and gentlemen, and welcome back to Down to Earth Astronomy. About a week ago, I uploaded a video where I remote control my ship only using a classic acoustic guitar. And as promised, this is going to be the technical video where I go over exactly how I do it, and I'm going to show you how you can do it if you want to try it out yourself. I want to see if you can do better maneuvers than I was capable of doing, which I assume you are. But anyway. The whole code will be available from direct download, so you can get the source code if you want to. I'm going to go through the source code here in a bit, but if you are new to programming, I'm going to try to show you how you can set it up for yourself. I'm not going to go through the whole installation process, but just how you need to tweak the code if you wanted to make it work for yourself. But anyway, on screen here we have the actual code, and this is written in Python 2.7. And the first thing we're going to do is we have a small import block up here where we import all the modules that we need. And of course, since this is 2.7, we're going to need the from future import division, because we want to be able to divide integers and get floats out and stuff like that. Then we're going to need a module called downtoearthastronomy, which is essentially the one we're doing to capture the sound from the microphone. NumPy, you should know that if you're a Python programmer. We're going to need to access the system and something called C types. Then we have a quick block here that it's essentially some C classes that's been rewritten. So just a few helpful functions that we're going to need. I stole these off Stacking Overflow, so not really a lot here. It's just because the way Elite works, you need to do a direct input, would actually send the hex code, so you need to redefine some functions. So that's what these functions here do. Then down here we have the two main functions defined. We have the press key that takes the hex key code as an input, and I'm going to put a link to a site where you can see all these hex codes for the different keys on your keyboard. And that's going to be in the description down below as well. So we have the function here that says press key and one here that releases the key. So because it's written like this, that you have the two functions separately, that means we can actually do multi-key in the future if we want to, because we can press multiple keys after each other and then release them as we see fit. But if press and release was in the same function, we would have to only press one key at a time. But that's just the functions we're using. That simply calls these classes up here that we're going to use to send that hex code directly to the current active window. Then we have a few variable definitions. We have the chunk size. That's how much sound, how many data samples we are recording each time we record a chunk of sound. And we have a sample rate here. So as you can see, we are currently recording 22,050 samples with a sample rate of 44,100, meaning we're recording exactly half a second. Format, that's the format we're recording in, and the channel, this is the channel we're recording from. So first thing we're going to do is we're going to define the audio, and we're going to open a stream. That means we can stream data directly from our microphone into an array in NumPy if we wish to. Now that we've set up the stream, I'm going to define down here a windowing function. And the reason why I do this is because we need to do our Fourier transform. And if you studied math or physics or any other of the natural science, you will know that if you're doing a Fourier transform, one of the conditions is you need to have periodic boundary conditions. And in order to get those periodic boundary conditions, I use this windowing function, which essentially reduces the amplitude of the signal to the edge of my recorded chunk. So this chunk half second here. At the edges of those, I will reduce the amplitude. But since we're only interested in the actual frequency of what we're recording, it doesn't really matter if we reduce the amplitude, because it's not going to alter the frequency. But if we're looking at the actual amplitude, we would have to, of course. So after we've done that, we just define the windowing function, so that's ready. Then we select a current key, which is of course none, because as we're currently not pressing any keys, and we're going to print the recording. And that's the print that you see when the program is running, saying, now I'm ready, now I'll begin to record. And then we have here data equals stream read chunk. So we're essentially just reading chunk number of data samples from the open stream, which is the current microphone that we set up here. We're going to do it with a transformation, so it gets into some wave data that we can actually use, and I'm going to subtract the mean to make sure that we remove any bias level that would be in the data. So if the mean of the data is not 0, I'm just essentially just going to remove where I said 0 is, just to clean the data a little bit. And then I'm going to apply my windowing function to reduce the amplitudes at the edges. Then I'm computing the standard deviation of the whole signal, because I'm going to use that to detect when I'm having an actual signal. So if I have a large standard deviation, that would probably mean that I'm having a strong signal. Then we're going into the fast Fourier transforming down here. I use NumPy's FFT functions to transform the data into Fourier space, and then I've written a small function here. Is that the whole? Yeah, that's all of it. And it's essentially I'm using an arctank function to make essentially it's a low pass filter that removes some of the noise from the signal, trying to remove some of the statics that will be picked up by the microphone or any other background noise. Just to clear the signal a little bit, I'm removing all the higher frequency and letting all the lower frequency pass. I can change the aggressiveness of the low pass function with changing this parameter. So if you have a lot of background noise, you might change that 0.2 to something else. If you want to clean it a bit more, but if you clean it too much, you won't be able to get the signal right. So I decided to use this because I think that fits fairly well. And then after we cleaned the data in Fourier space, we're going to move it back into real space, again with the IFFT function in NumPy. Then, now that we have the cleaned data here, we're going to what are we doing here? We are computing the maximum frequency of the data, and we're getting the arc max. That's the maximum, the argument where the maximum is found, of the absolute value of the Fourier transformed or cleaned data. And then of course that's just what we get here is not really the frequency, it is the wave number. So I'm dividing it by the number of data samples and multiplying it by the sample rate, so that gives us the actual frequency. So I'm setting now that I should have said we are inside a while true loop, so this is just going to keep running and running and running around until we stop the program. So I switch over, because imagine I've been running around once, and I want to store the old key so I know what kind of changes have happened. So I store the old key as current key, and then I set current key to none, because as default I don't want to have any keys pressed. And then I says if the standard deviation of my signal, that means I just figure out the range around larger than 150 is good. That's where it reliably detects the signal for me, and I don't get any false presses for background noise. And again, the standard deviation was essentially the strength of the signal that I'm getting. So I commented out a line here that says print max frequency. I used that when I tuned the program, because as you can see on here, we have a lot of frequency ranges. And if you want to have a specific note, and you don't know the frequency range or where it is in the whole spectrum here, I would just uncomment this, and each time it found a signal that's strong enough, it would essentially go down here, and it will print the frequency. So when you have to tune your program for yourself, you uncomment this by removing the hashtag in front, and it will show you the frequency once it detects one. And you can then use that frequency down here when you are putting in all these numbers down here. If you're not getting any signals, try to lower this number to a lower value. That might depend on the microphone you set up and if you have microphone boost and all that kind of stuff. So try to fiddle around with this number if you cannot get a good signal from the program. And all of this down here, this is essentially where I define the different keys. And you can see I set some frequency ranges. What I would often do is I would find the frequency that fits what I want to do, and I would put a 4 Hertz span on each side, just to have a little bit of room in case of small variations if I bent the strings slightly or something like that. Then I print what it is, both so I can see it on the prompt when the script is running, but also so I have an easier time figuring out myself, so I know that, so 06 2D, that's of course full stop. I mean, that's obvious. no, but that's why I write it here as well, just to make it easier for me to decode or to debug it, and to see what block each of these statements actually are. I could have done this with a switch, but I didn't. If statements worked, and this just to be quick and dirty. So essentially I define all the different key presses, and again you look up in the table that I've linked in the description what the hash key for the different keyboard key that you want to press is, and you write them here, and of course have to match what your settings are in Elite Dangerous or whatever game you want to implement this into. So I have full stop, 25% thrust forward, backward, thrust up, down, left, right, and I have two lefts, as you can see. And noticed here that I did remove many of them, also the roll, I have two of them as well, and that's because notice here the frequencies are doubled, in most cases, almost doubled in most cases. And that's because that sometimes my FFT analysis up here would pick up a higher, so the double frequency instead of the actual frequency that we are looking for, and instead of trying to detect when it's done that or when it haven't done that, I decided to do multiple frequency bins for each key, so I would both get the base note but also the double frequency when it was needed. So that's why some of them are here twice, and you might run into the same problem. So again, we have roll left, right, we have landing gear up and down, and we have pitch up and down. And then the final thing we're doing is we're saying, okay, so if the current key is not equal to the old key, that means there's been a change in the key configuration here. Then, if the old key was none, that means, so if we previously didn't press any key, but now we are pressing a key, I'm doing a press key with the current key. So again, if there's a change in the key, and the current key is none, that must mean that the old key is different from none. That means that we previously have had a key pressed, but now we're not pressing it any longer. So I'm doing a release key. And then in all other cases, that means that we pressed one key in the last circle, or in the last loop, and in this loop we are pressing another key. Then I'm releasing the old key, and I'm pressing the new key. And that's pretty much it. I have 3 lines commented out down here. That's essentially to stop the stream, close the stream, and terminate the Python audio module. But since all this is running inside a while true loop, that means it's never going to actually end up down here. I'm just going to control C out of the program when I don't need it anymore. But that's basically it. Again, I will put a link to the description where you can download the code for yourself. If you haven't seen the other video where I actually use the program, I highly suggest you go over and click on the annotation here on the screen again. And watch that. And yeah, that's pretty much it. Subscribe if you like the video, give it a like down below, leave a comment, tell me what games if you're going to use it, and please tell me, show me, I would love to see it. And until next time, I'll see you in space.